Alright, so in this last section, we're going to learn about binomial expansion. So really that's just expanding a binomial, and it's really just an extension on summations / sequences and series. So we're actually going to first introduce this in this chapter, and we're going to come back to this when we start learning about probability in the next chapter. So first, we're going to consider expanding the expression x plus y. So x plus y, if I'm going to expand it, first I'm going to square it. So x plus y squared, well that's x plus y times x plus y. Now this is pretty simple. Multiply, you FOIL, so we get x squared, then we get plus xy, and we get plus xy again. Now I like to keep my x's first and y's second so that I can see the terms that are like each other. And plus y squared. So ultimately this gets us x squared plus 2xy plus y squared. So now let's expand x plus y to the third power. Well, that's x plus y times x plus y times x plus y. Well, since I already did this, I'm just going to take our expansion here and do x plus y times x squared plus 2xy plus y squared. So now this just requires a little bit more foiling. So we get x times x gives us x cubed, and then x times 2xy gives us plus 2x squared y plus 2xy squared, and then now I'm multiplying the y through, so plus y times x squared, so x squared y, because I'm going to put the x's first again, plus 2xy squared and plus y cubed. So now put your like terms together. So we got an x squared here, and we've got an x squared there. We've got a y squared and a y squared. So bring it together, x cubed plus 3x squared y plus 3xy squared plus y cubed. Alright, and you guessed it, we're going to go and try and do the fourth power now. So again, I'm just going to take this and do x plus y times x cubed plus 3x squared plus y plus 3xy squared plus y cubed, and now FOIL, so 3x times that, so this. Well, this is starting to get pretty tedious. Let's go back and see if there's any patterns that we notice here. So if I go here, notice there's an x squared, then an x cubed. Well, what do you think this is probably going to start with? X to the fourth. So that's one pattern to notice there. Starts with the first term, and we're cubing it. Well, then what do you notice next? Well, if this is power 2, look what it goes to. 1. Oh, let's not look at that one. Let's look at this one. It goes to the power of 1, and then it's non-existent. So first term has decreasing powers. So first term has decreasing exponents. Starting with the power. Well, similarly, let's look at y squared. Well, y squared, we've got y cubed, and then you bet that this is going to end with y to the fourth. So the second term is increasing in exponents. Look back, it started with 0, then you have a 1, then you have a 2. Starts with 0, then you have a 1, then a 2, then a 3. Starts with 0, 1, 2, 3. So there's another pattern there. So second term increases exponents starting with 0 power, which really means it doesn't exist. But we're left with, how do we find these coefficients? We've got 1, 2, 1. 1, 3, 3, 1. 1, well, what's in the middle here? I don't know. So how to find coefficients? Well, let's take that pattern and think about it. There's one thing we can do here. I'm going to start off this with a 1, and then I'm going to do the 1, 2, 1 pattern. And then I'm going to do 1, 3, 3, 1. So I'm taking that from those things we had before. Notice I keep starting with 1. Well, if you take 1 and 1, add them together, you get 2. If you take 1 and 2, add them together, you get 3. If you take these together, I get 4, but now I have a middle number, 6. And then I have 4 again. So notice there's a pattern that's kind of emerging here. 1, again, take it together, you get 5, 10, 10, 5, and then your 1 on the outside. And I can keep going. I can do 1, 6, 15, 20, 15, 6, and 1. And let's go ahead and put these with the powers. Well, this was when we had a power of 2, power of 3, power of 4, and so on. So this would be 5, this would be 6. This is known as Pascal's triangle. This is one way to think about how to get the coefficients on expansion. The other way is to think about this as a summation. So number 2 would be thinking about it as a summation. And I'm going to call it combinations, and that's a little bit of a preview to what you're actually going to learn in the next chapter, combinations. So think about this. We started with 0. We ended with the power, with x. So if I want to do the sum, I'm going to start with r equals 0. I'm going to use r for a reason, and you'll see in a second. I'm going to go to the power n. These terms are all from the formula n. Choose r, which is in your calculator, and I'm going to show you it on the back side when we get to those. Now, x started with the highest power, but we're actually going to subtract out r as it increases. And then we're going to take y, and that's just going to be to the r, starting with 0, going all the way to n. So this would be the formula for it. Well, what is this n choose r? It's really n factorial over n minus r factorial times r factorial. What's a factorial? 5 factorial is the same thing as 5 times 4 times 3 times 2 times 1. All that means is keep multiplying by 1 lower. So 8 factorial is 8 times 7 times 6, and so on, all the way to 1. All right? But this is actually in your calculator, so you don't need to know how to do this right now. All right? So we're going to go back to this because this is a little bit confusing, and we're going to use it, though. So I want to expand this, and then I want to write the summation. While it's the 5th power, I can look back at Pascal's triangle and figure out, well, if it's a power 5, it's going to have these coefficients. So power 5, I know I need a coefficient of 1, 1, 5, 10, 10, 5, 1. So that's one way you can think about it. That's the coefficient. Now I need the term. So I need 3c. Well, the first term, remember, let's think about it as summation, is going to start with the highest power. So I'm going to start with the 5th. The second term, if there's a negative, you better keep the negative with it. Negative d to the 0. Again, start with highest and no power. Now let's just decrease power. So 3c to the 4th, 3c to the 3rd, 3c squared, just 3c to the 1, and 3c to 0. Now the zeros are going to go away. You should notice that this is actually going to give us an alternating pattern. So now I have negative d to the 1st, negative d to the 2nd, negative d to the 3rd, negative d to the 4th, and finally negative d to the 5th. Again, I'm going to connect this to the summation. If you prefer to do the summation first, that would be fine. So let's go ahead and multiply these out. Well, 3 to the 5th is 243 times 1, so that's just 243. C to the 5th, and D is not there. Alright, 5, 3 to the 4th, well, that's what, 81 times 5, though, so 405, and then it's negative 405. C to the 4th, D, first power. You don't have to write it, though. 27 times 10 is going to be 270. Negative is going to be going away because it's squared, so this is 270. C to the 3rd, D squared now. And keep going. 3 squared is 9. 9 times 10 is 90. The negative will be here, so negative 90. C squared, D cubed. 5 times 3 is 15. No negative, so 15C, D to the 4th. And finally, negative D to the 5th. But you need to put it all together, so you really need to write this in the end as 243C to the 5th minus 405 C4D plus 270 C3 D2 minus 90 C2 D4, oh, nope, D3, plus 15 C D4, and I ran out of room, minus D to the 5th. And that is really the whole answer right there. But I kind of use space here to go ahead and find each term, and then I put them together. Now, summation. You might want to just start with summation and then get all the terms. That would be fine. So I know I have a sum. R is going to start at 0. My power is 5, so n is 5. And now I'm going to start with n choose r. And I'm going to go from, let's see, first term, so 3c to the n, or, oops, 5 minus n, sorry, 5 minus r, times negative d to the r. So if I were to do each of these terms, I would start with 5, choose 0, because n is 5, choose 0, and then I have 3c, 5 minus r, so 5, and then d, r is 0, so that's the first term. 5 choose 0 is just 1, and this is where I'm going to show you that in your calculator, so that you know where exactly I can get those combinations from. So if you go, put in your 5 first. If you go to math, arrow over to probability, again, we're going to do this in probability, go to NCR, it's right there. Now if you have a calculator like me, it's going to automatically put it as a subscript. If you don't, it's not going to put it as a subscript, you got to follow the command sequence it gives you. So I can do 5 choose 0. I get 1. Well, what's 5 choose 4? Let's just go with that. So 5, math, probability, oops, choose 4. It's 5. Again, 5 choose 4 is going to be this term here. So that's how I got all of those terms in my expansion. So you can kind of keep going there, plus, dot, dot, dot. The last term will be 5 choose 5. 3c, again, there's going to be no term there because 5 minus 5 is 0. Negative d to the 5th. But, again, these all come from 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5. That's where these terms come from. Or, again, we took them from Pascal's triangle. However, something like this one, I didn't get the 8th row of Pascal's. And do I really want to sit there on a quiz getting every single row? No. So that's where using 8 choose 1, 8 choose 0, 1, 2, 3, 4, 5, 6, 7, 8 works. Now, I want you to just find the first 5 terms here and write out the summation of the notation. So write out like the summation here. Remember that this is going to be your x and this is going to be your y. Right? So before trying that one, let's go through one last thing. Sometimes you may just be asked, hey, find the fourth term of this series. Well, how do I know the fourth term? Well, let's develop a way. Well, I know I'm going to start with x to the 10th power. Then I know I'm going to have x to the 9th power. Well, then I know I'm going to have x to the 8th power, x to the 7th power. Well, this is where the fourth term comes in, but I need the coefficient on that. Well, if this is 7, how could I get to 7 using 10? Well, 10 minus 7 is 3. Notice fourth term, well, that 7 comes from, or fourth term, you want actually minus 3, so you need to do r equals 3. How do I get there? I do 4 minus 1. You're always going to do 1 less than what you want. So third term, you're actually going to have r equals 2, because you need to do 3 minus 1. Alright, n, well, we know n is 10, because that's the highest it goes. Well, I can just pop that into the summation formation without even writing it, because I know n choose r should be 10 choose 3. That's the coefficient. Now I need x. Well, I just said, hey, that's the 7th power. Well, notice how these always add to the power. 5, 5, 5, 5. So I know I need negative 5y to the 3rd power, because these need to add to get you to 10. So let's go in our calculator and figure out what 10 math probability, choose 3 is. It's 120. So this is 120. X to the 7th is just x to the 7th. Well, this power, remember, belongs to the 5 and the 3. So negative 5 to the 3rd is negative 125, and then I got y to the 3rd. Make sure you multiply those together to get negative 15,000, x to the 7th, y to the 3rd. And I have found the fourth term. Alright, I already did r for you, but you need to finish this off. So make sure you finish this one, and make sure you go back and finish just the first 5 terms of that one. Alright, and then we'll talk about it in class, and we'll spend a little bit of time on this because it is a confusing topic.